Okay. Good afternoon. This is Dr. Abbasi for Essence of Science, and it's truly my privilege to have this conversation today with somebody who's living my dream, building a machine that always has been in the back of my mind. I apologize today, our pretty one, Amanda, is not here, so you have to just bear with us alone. With me is Misha.
Hi, my name is Misha. I am the CFO of Inspired Spine.
And as well, artificial intelligent person with us. Now, with us, we have actually James Lyman. James, why don't you introduce yourself? But you're my hero.
Oh, boy. My name is James Lyman. I am the CEO of CGR Tech, which is automated, fully automated machinery, and then USA Botics, where we automate factories and help people to bring jobs back to America. And then our newest company, 6 years now, is Mudbots. We build and have developed the technology for large 3D printers, which can print homes at about a 90% savings. So
wow,
it's a pleasure to be here.
Well, thank you for being here. Now, I have a first-hand observation by one of our by our director of Da Vinci 3D, is a company in Texas that wants to bring this technology to Texas. Chase, why don't you introduce yourself? And I want your first impression of this technology.
What a pleasure to join everyone this morning. My name is Chase Whitaker, and I'm the president of Da Vinci 3D Tech here in Texas, where we hope to make a lasting impact on the housing crisis. I had the pleasure of visiting the Mudbots manufacturing facility this past week. And let me just tell you firsthand, as soon as the machine started, we had a smile on our face from ear to ear, and it didn't come off until we actually left the facility. It was being in the presence of some very ingenuitive minds and some great minds. There's a great vibration, a great spirit that manifests this type of thinking, and it's a pleasure to be there.
Well, this technology, even though it is very, very new, but it's based on lots of other technology that has existed for a long time. Like, people like me, we know that we used to have a typewriter. I mean, people don't use that anymore. In a typewriter, every letter was an impression or some kind of 3D thing that it would go and hit on a band that has a ink on it and write letters on a piece of paper. Then later on, we had a machine that actually would deposit a small amount of ink in an array and create those letters for us. And then all of a sudden, we could print more than just one kind of letter. We could use many different kind of letter and even pictures and so on. And it wasn't long before some companies, I think, they understood they can, instead of just the ink, they can deposit material. But why am I talking about this and not you, James? So tell us about the background of this technology.
Well, the process of 3D printing technology is dispensing a layer by layer, just like in traditional. If anybody's ever watched a 3D printer, it's mesmerizing. Just to watch layer by layer by layer and watch somebody build something that would have required molding and just days and days of pre-work to get to the point where you could actually build a structure or a shape. And we're talking little things, but there's a book that is out that it's the Fourth Industrial Revolution. And it's a very fascinating book. We have a machine that was purchased by a university in Arizona, and I saw it in the airport and picked it up. And I was reading through this, and I'm like, the guy's like a prophet. He's speaking of the book was written years before concrete printing or cementous printing had ever been developed. Yet he was so fully explaining how it was going to revolutionize our time. It was a fast read, not a real big book. And I just got caught up in it and reading, letting me know what the future was going to be. So it was fascinating to be, in my hands reading what I was experiencing at the time. So right now in America, we have such a tremendous need for just one of the basics of life, an affordable house, a place for people to raise their family and their children and to be safe. And we take a lot of that for granted. A lot of places around the world, this isn't something that everybody gets to enjoy. In fact, a vast majority. And so, but the technology itself is essentially a very large 3D printer. There's not a lot of magic in a large scale printer. They've been out now for 20 years and have become commonplace. I saw this about 7 years ago. For the first time, I saw a YouTube video of a Russian gentleman, Andreyko, who had built in his backyard a castle for his daughter, a little fort. And the moment I saw it, because of my construction background, my family has, growing up, that's what my father and family did. So I knew immediately that this is going to revolutionize everything. Yeah. It's going to change the way we look at housing. And for the first time ever, it actually makes affordable housing possible. Yeah. You have governors and senators and different people all around the world that are like, their campaign promise, I'm going to help fix affordable housing. In retrospect, there's very little they can do. They can't force people to contractors to bid work for less than what they can get in the standard market just because it's government. They can't force Home Depot to sell 2x4s for less than what they sell to the general public. So short of just giving some free property to bring down the cost, there's been very little they could do. This is the first time when good people that have a desire to make a difference are empowered to actually see that difference come to light. Yeah. So for the cost of essentially sand, cement, and lime and a few additives, we're able to print a house that is the strongest that the world has ever seen. It's not susceptible to termites or mold or fire or hurricanes or earthquakes. We just saw the travesty in Hawaii. And as I look across that, what's left of the landscape after the fire had ripped through all of that, the only thing left are chimneys or concrete foundations.
No, actually,
it's a shame that the whole house hadn't been printed and people could literally put on a new roof and half the house is still standing.
Yeah. Now, one of my strongest men was as well with Chase there, and I saw a video. He was swinging in a hammer on one of the test structure, and he couldn't take it down. And that was amazing. And that we are talking about, on a structure that is built. Chase, you were using an analogy that if you blink, there's another 6-inch. What did you say? That, how fast, how efficient this machine is. Yeah, I want you to say your observation, but I want to still go back and talk a little about the technology behind it, because this is amazing technology. So, Chase, how was the efficiency and speed of this machine?
It was incredible to be witness to, just the speed combined with the quality of the actual print. And I swear I walked away to take a quick phone call. I came back and 2 more layers had already been erected. So don't blink or you'll miss another 3 or 4 inches. It was incredible.
Yeah. Now, we talked about the inkjet technology. And about 20 years ago, I could buy a 3D machine, a 3D printing machine that would print stainless steel or titanium for medical devices. And it was very interesting. It would put a macrometer of layer of powder, and a laser would go and melt that exactly where it needed to gather, and then add another layer, and the box was 10 inch by 10 inch by, I think, 10 inch, meaning anything in a cube of 10 inch, that machine could build from stainless steel or titanium, anything you could imagine. And that actually, we have a 3D, we have what we call a Swiss lathe. This is the highest level of production that makes amazing things. But by being able to truly 3D print, that takes you to a different level. There are, even with the most advanced Swiss lathe, there are things that these machines are not able to do. But practically anything that you can design on a computer program, more or less, a 3D printing machine, more or less, can print. Now, the printing plastic and metal, it is pretty refined. You can go buy those machines and they come and install it for you. We could order it and we could have it by the end of the month and start. Those are standardized. Oh, James, this is a question for you. What technology that you are using is taken from those technologies, and why did it take what you are doing so much longer, like 10, 20, 30 years longer? What are the difficulties to take that technology applying to what you are doing? Is not, I cannot imagine it's just a scaling. Tell me a little about the science behind what did you take from those technology? What did you have to add to overcome those problems?
Well, the pioneers of those technologies are the building blocks, obviously, of what we're doing today. And so, of course, we take everything we can. One of the exciting things today is just the introduction of mechatronics students and the education that's available in universities around the world. So we were able to, we brought in a lot of very bright and intelligent people. Now, we had no question that we could make the nozzle move through CNC through an XYZ motion. We knew we could do that. We do that every day for people that are trying to automate their factories. What took so long is that you're not printing with ABS or PVC that bonds immediately and cures, becomes hard fairly quickly. We're printing with a cementous material that is gradually changing the entire time that you're printing. And so we spent first whole year was just playing with different cementous materials. There's 100 different ingredients in any type of cementous material, or that you could choose from plasticizers and graphene and hemp, synthetic fibers, and on and on and on and on and on. What happens when you put sugar in it? What happens when you put salt in it? And those are real things. You can go YouTube that stuff, and we've all been down those rabbit holes. But it was building the printer wasn't the challenge. Building a batch plant that will automatically adjust the ingredients with an algorithm based on temperature and humidity, your mud temperature, your stator temperature, and all these different things. That data has to be put in, but once it's in, it's a batch plant with logic. Chase had an opportunity with his team that he brought out to hand batch several days because that's what almost everyone in the world is doing. most of the companies around the world, they're trying to sell the Epson ink for the Epson printer. That wasn't a direction we wanted to go. We knew that for our mission and what we're trying to do, we want to bring affordable housing throughout the world. In order to do that, we have to give them the materials that are in their own backyard. And so it makes it a little more complicated and challenging. They got to connect a few dots when they get home, but that is how they optimize the affordability. Most everywhere we have sand, cement, and lime, and a concrete specialty company that can get you the other ingredients that are necessary. So we spent a year and a half, 2 years just watching prints fall over and fall over and fall over. It was very depressing. It was very frustrating. But we reached out to some very intelligent people and kept going and kept going and the possibility of what it could do meant that we could never give up. There was no choice of just giving up. We just had to test and test and test and test. And so the magic's primarily in the batch plan. It's in the software. It's in the slicing software, because there's no off-the-shelf slicing software that will do the kind of things that we need to do. And there was no batch plants around the world that had logic. You set them, and they would meter your ingredients every single time the exact same way, but they couldn't automatically adjust. And so that has taken a considerable amount of time.
Yeah, infrastructure. I see that as well in my business, which is in medicine. Doing the surgery is the smallest part of the action, the peak of the iceberg. Setting up the environment, all the protocols, setting up the right team together, and so on, putting the ingredient in the right proportion together, what makes, I think, any endeavor successful. It seems that you are there. Now, let's go back a little about the overall construction in the United States. I hear words like, affordable housing. I hear like, this is a problem. No question. People, the housing price has increased tremendously faster than average person's income. Now, if you don't have rich parent, you cannot afford a house anymore.
No.
So you are actually solving an epidemic problem that people want to live in their own house, but they cannot afford that. Well, just considering that the human resource and what you pay people is the most of the cost of any business in the United States. Now, I was in India. Human resource is not the most expensive part of their problem.
No.
In the United States, it always has been, and as a matter of fact, some people criticize that, but I see that that's why we want to automate things. That is why, for us, it's always more important to put money in technology that reduce our reliance on human resource. But give us an understanding, a traditional build versus a 3D build. Compare that on the material cost, on the labor cost, and the timeline, and so on. What are we getting into here? I mean, what are the advantages with some numbers, if you can?
Well, what we're getting into is a process that's more manageable, with a reduction of individual subcontractors that are necessary to get something built. We are faced with a shortage of qualified skilled labor in the construction industry, and less young adults are interested in getting into that field. In two of the universities that we're in right now, they said they couldn't get anybody to sign up for construction management anymore. And our contractors out in the field, they're feeling that. Nobody wants to do that. The minute they announced that they're offering construction management using high technology 3D printing, it's standing room only. They greatly underestimated how many people were going to sign up for that type of a course, and it made it amazing and exciting. And the kids that are coming in to do that, the kids are a little different today. They got to feel like they're going to make a difference. They have more humanitarian thoughts and considerations than it seems our generations, but they want to be behind something that's going to make a difference. And so this empowers them to do that, and with amazing careers that are going to take them all around the world. I mean, we're in Ghana, we're in Guam, we're in all parts of the world where they're building thousands and thousands of homes for people that don't have them. So, and like I said, we take that for granted here. I grew up very poor. I grew up with a single, 16-year-old mom, trying to make ends meet, and just very, very challenging. I grew up feeling less than, unimportant, no future. I didn't have the resources for college and all of these different types of things. So for me, it was a passion to make a difference. I knew that this was possible now. I knew we could do it and we could figure it out. But I was driven by, as you get older and older, I guess you start looking at what are they going to say to me about me when I'm gone. And hopefully, when it's done, someone's in heaven someplace pat me on the back and say, you know what, you're a pain in the ass, but good job, kid. You did a good job. So,
well, you will definitely leave a legacy, a big one. I can guarantee you that. Now, Chase, you have been in construction for so long. What is the average price of a one-family house in Texas? I know that the average price of one-family house in Minnesota is $270,000 to $300,000, but that is the average, and these days, you cannot build a house for that price anymore. No, but you have been in construction, Chase, in Texas, in major cities like San Antonio or Austin, where you are, correct? What is the average price of a house? How much would that cost if you would build it now, not to go and buy one that's already there? And maybe that's a discussion between two of you. What are we looking if you build the same house with this new technology? What is the advantage price-wise, affordability to a young family? Can you start with that, Chase?
Yeah, sure. I mean, right now, it seems like with each passing week, the average median home price is ticking up, right? And it goes back to what James mentioned earlier, supply and demand. There's a huge demand, very little supply. That's basic economics, right? If you got a ton of demand and little supply, you've got leverage against the general public. Right now in San Antonio, prices on average are closer to $300,000 for a 1,500 to 2,000 square foot home. To address the material cost, it's all about what's in your backyard, right? So we're seeing in some of our pro formas that we could, save up to 60% in material and labor costs. And I'm being a little bit conservative with that number, depending on how you had mentioned, so much is in the setup. It's like they say in Hollywood, you hurry up to wait. So much of what we do is in pre-construction, preparation, and all that. And then once the machine starts going, it's like NASCAR. And like I mentioned earlier, don't blink, because 2 hours later, you've got, a 40-inch wall up ahead. So the applications of this are, so worldwide. And with DaVinci 3D, we're not just thinking about new homes. We're also thinking about disaster recovery. If there's a hurricane, if there's fires in Maui, this type of technology can be, basically
game changer.
Yeah, it can be mobilized rather quickly. You can get the printer up, in less than an hour, and you could print and replace a home that someone's lost or been displaced from fire or, hurricane or anything like that within a couple of days, and get them back in their home within another week or two. So we're trying to have this application across different, faucets here in Texas.
No, that considering, you mentioned that I heard about price reduction 40 or 60% overall. And, what percentage of that is material? What percentage of that is labor? Can you, as somebody who's not familiar, I'm not familiar with the construction, when you build a regular house, what percentage of the cost goes to material versus labor? And this new technology, how does it change that calculation?
Yeah, well, the labor is really simple because with 3D printing, you eliminate, up to 7 trades. Okay, you're not hanging sheetrock, you're not taping, you're not floating, you're not painting, you're not paying a stucco guy in the exterior to do siding. All that stuff is eliminated. So it's probably about 50-50 material, 50% labor. Typically, James can attest to this more so than I can. On a 3D printed job site, you're going to have your team, which consists of 3 to 5 people at the most, on a job site. Conversely, on a typical residential stick frame construction, you could have anywhere from, 7 to 15 people in there, hanging wire, sheetrock. I mean, just kind of a safety disaster over, a couple of months. So your savings in time and labor are 4 or 5-fold versus traditional stick frame.
Okay.
If I can speak to that for a second, in Utah, our cheapest home around 1,000 to 1,200 square feet, it's $430,000.
Wow.
Most of our kids are getting out of school. They're 100 grand, 200 grand in debt. And to get their life started, they got to come up with 20% of $430,000. It's just not happening. And we really don't realize how damaging we've been to their futures and everything else. If you're renting, all your money is going to tax. You're going to get taxed on all that rent. They don't get the benefit of home ownership or to see the value of that home increase, which is where most of our families actually made some money in life, not going to work every day, because most people will live to 90% of their income. It's if you buy something and over time, the value of it goes up, and that allows you to retire one day. So we eliminate the first 7 trades necessary to get to what we call walls up. Traditionally, that means that the footings have been done, the slab has been done, they framed it, they sheeted it, they drywalled it, they taped it, they stuccoed it, they put their electrical in, they put their plumbing in. All of that normally takes a month and a half to 2 months, we do in 1 or 2 days. We're putting the electrical in the wall while we're printing. We do the plumbing while we're printing. We finish the inside of the walls while we're printing so that they look just like drywall. There is no need for stucco because what we're printing is aesthetically pleasing. And I tell people all the time, if it wasn't cheaper or faster, people would still have to have this within 5 years from now, because aesthetically, you're able to print designs that make so much more sense. So much more withstanding to hurricanes, and it's a monolithic rock. You just print monolithic pours, not a whole bunch of little cinder block put together, because every time there's an earthquake and you get a little bit of side-to-side movement, all those blocks crack and fall and walls fall down on you. This is one solid monolithic pour, layer by layer, that's all bonded together. But you're eliminating a month of work. You're eliminating a month of subcontractors with 3 to 4 people showing up to jobs in their trucks and the gas. We're eliminating forests of trees that aren't being cut down anymore.
Environmental side of it,
in every way. And when you talk about to run the house, to heat it, to cool it, and all this here, you won't have a more energy efficient home than this.
And I noticed that actually, that energy efficiency, in Germany, most of the houses are built out of blocks and cement and concrete. Most of the houses, they don't have AC. They just don't. And here, you couldn't, because the way we build a house, even in the best insulated house, it's just building a house from concrete, and it's more energy efficient. But now, but talking about Germany, for a very long time, there is this device, this robot in Germany that is practically like a conveyor belt. The conveyor belt brings these blocks of cement blocks to a robot head. The robot picks it up, he cuts it, even if it has to apply an adhesive and build commercially big structure and so on. Now, what you do is not that. It's not like putting blocks together. Truly depositing layer by layer, like a 3D, like an inkjet printer that deposits layers of cement. And obviously, my understanding is that then you can truly print whatever can be designed on a computer in your brain. Hence,
Whatever
the
you
name
think.
of our episode, Printing Your Dream House.
Mm-hmm.
What are the limitations today? What with the machines that are available, and if you don't mind, go into what is available out there, and what is the limitation? What can you print today? Before we talk about what the future of this is.
Well, currently there's 10, 12 different companies that are trying to develop the technology a little bit like us. They looked at it on YouTube someplace and they're like, hey, my kid's a mechatronics student. He can build that. And then that's when the learning begins. So the years and years of watching stuff fall over and get there. But there's only 3 companies in the world that are actually selling machines. Naturally, we're going to say we lead the world in this technology. But when I say that, it's not just to be, obnoxious. If you're going to build a machine that is going to 3D print, then it has to be faster and cheaper. And if it's not, then it's just a novelty. And it actually makes the cost more expensive. So I can 100% say that our product is faster, cheaper, and better than any product in the world. And it's because probably I come from a construction background. I swung a hammer, I scrapped out houses, I spotted nails. So and then I had my own construction company in Nevada with 150 employees. And it's just a lot to manage, but it has to be faster and cheaper. And we built a machine that sets up faster than any machine in the world. I mean, there are machines that take weeks to set up. Our sets a 3535 printer. We set it up in the record right now is 39 minutes. And that's a record. That's a record at Mudbots, where we are training. We have a month-long training that our buyers come to. And that's after a second attempt. They did their first one. They kind of figured out what they're supposed to be doing. They tried. So the cost doesn't begin when mud's coming out of the nozzle. The cost begins when the truck shows up on the job site and you got to start unloading the printer parts and putting it together. So we're the only ones that print and don't stop. Everyone else around the world, they stop about every 6 to 12 inches and they go home. And they go home because if they keep trying to print, it'll fall over. That's that 2 years of watching stuff fall over. Most of the people, I guess, just like, okay, this is the limit. You can print about 12 inches. Anything more than that's vulnerable, and the wind might blow it or the rain might get on it. So we're going to cover it up and go home. And we knew that would never be faster or better. And so we kept pushing and pushing and pushing. It was millions of dollars in years of R&D before we even got to sell our first printer, So yeah. I understand the temptation to get it out in the public and start selling machines. But if the machines aren't ready, you're going to ruin the reputation of this technology rather than escalate it. And the one thing that we really got wrong, most of the directions we decided to go were pretty spot on. And not because I made those decisions, because I put together a team that would argue with me, could stand up to me and say, James, you're wrong. If people agree with me all the time, I just don't need them. I need people that can tell me I'm wrong and then prove it to me. And so we fight and argue about how we're going to build the machine. And the engineers always want to just make it the most complex, ridiculous thing in the world. I'm like, I'm selling this to contractors. It's got to be simple and easy, or they're not going to buy. It's like selling a space shuttle to a contractor. And we got to simplify it to where it's like buying a scooter. So it's really Chase group just went home. They printed some beautiful print. They went through a ton of training and stuff. It's the training is essential as the printer itself, but I think Chase can say just from being able to take it apart and put it back together, it's pretty simple, stupid, and we had to make it that way. So it's important to understand, however, that 35-40% overall cost of a house, but the effectiveness of what we do is just getting to where we have walls up, and then people are putting trusses. Now we're working on post-tension trussing that can be printed and SIP panels that can be printed, because people are like, wow, this thing's phenomenal. What else can we make it do? we're in our genesis. We're just barely touching. I mean, I remember when 3D printers came out and they were printing with ABS and then PVC, and then they got all these other types of mediums to be able to work for. Now it's like, holy hell, we're printing steel. Are you serious? No way. I see where we're just in our genesis. Every year I look back at the previous year and I'm like, we didn't know nothing last year. And finally feeling like we're on top of the world. A year goes by, we look back and like, man, we were idiots last year. Why were we doing it that way? So the machine works, it's efficient, it's marketable, it does everything we say it will do. All we're doing now is making it easier and faster, more fail-proof. So it's just exciting as hell, because the countries that are calling now, there isn't a major city in America that doesn't have a home deficit of about 10,000 homes.
Yeah.
And there's no solution until now.
Yeah. Now, 2023, this year, or even next year. So there is a slab foundation. The machine builds all the walls, all the perimeter of the house. And then obviously you don't have to put anything outside or inside. You can if you wish, but you don't have to. Plumbing and the electricity is already built in.
50% done.
But then you have to put roofs on. And the roof is, at this point, still the traditional roof. Is that correct?
Yeah, we're seeing most people are putting on a SIP panel, or they're pouring a lift slab roof and just sticking up on top if they're in a hurricane type environment. But you raise a good point. I mean, we don't print carpet, we don't print porcelain, windows or doors. So it's important to understand what we do, what the printer is efficient at. And we can make a significant difference there. We can't change the cost of your carpet. So, but we can get a month and a half, 2 months worth of work done in a day or two. You roll the printer to the next spot, you print again, and roll it again and print again. It's most efficient when it's done like Henry Ford, an assembly line. Print, 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 print.
And it can be curved, right? Everything can be curved.
Oh, the design, it just, yeah, what you can do with design, you walk into these things and they're so much more open and spacious, because it's not, everything's just a box. Our blocks are squares. 2x4s are straight and for squares, and paneling and everything else. It's not a very aesthetically pleasing type of print. But as far as energy efficiency and durability to the outdoor elements, not even close. Not even close.
Yeah. So, well, in 2023 and 2024, most of the perimeter can be printed, and there are technologies I hear that enables you maybe even to make the roof more hurricane resistant, and some other those technologies for the roofing. Is it already there, or is it something that you expect to be in the next year or two?
No, it's already there. It's just trying to come up with the processes to make it like a dome roof is your strongest, most enduring roof out there. There's no corners to pick up with the wind and stuff. And so it's just the process of building that, because as I'm building a dome roof, there comes a point where what I'm printing is literally on air.
Yeah,
so
yeah.
The fastest way to be able to support that roof so it can be printed is that's what's in the works right now. And then of course some post-tension stuff, and then some SIP panel where the printer is actually going to be printing a closed cell foam sandwiched between two pieces of OSB 5/8 and all thread. And you pick the whole thing up and stick it on top. It's just fast. You put a roof on in an hour, not days.
Wow. When do you think that's going to happen?
It's there now.
Oh, wow.
It is there now. The SIP panel one, we're still working on. Spraying that foam is challenging because it just expands and expands and expands. But we've been experimenting with it. But SIP panels have been around for forever. They're just, the application of them hasn't been as prevalent as this. It's the same thing with cementitious chemistry. The stuff we know about that is just very minute. there hasn't been a big industry for cementitious chemistry. Now all of a sudden there's like, oh my gosh,
Yeah.
can we print homes with mushrooms? Can we print homes with hemp? Can we print? So it's just coming out of the woodwork, the intelligent people that are approaching us and saying, with your machine, our application comes to pass.
Yeah, that SIP panel, I'm not familiar with that. Would you mind to explain that a little?
You bet. SIP, it's an insulated panel, 5/8 of plywood on the top, 5/8 on the bottom, and then you have solid foam, R32, and then they're using all thread to go through it to make it just sandwich it. So they can pick it up as one unit and just, you can build walls with them. You can, but most commonly it's the roof that makes it so fast, so that I can do a roof like this, put this piece on, it's done in minutes.
And now, what about, what do you think in the next 3 to 5 years, or even maybe next 3 years? What do you think what is the future technology that people who are looking to buy a house should be looking into in this technology?
Well, the future technology is going to be, I went to, I go to a lot of different trade shows and look at this kind of stuff, but you're going to have paints that are the screen. You will have walls that you can just put your cell phone on the wall and it will charge it. You can walk room to room, and whoever you're talking to on your cell phone will just go room to room with you. We've already seen smart appliances. When I went to Beijing and went to, Shanghai for the World Fair, I walked into a house where this was happening. I saw smart appliances. None of that stuff existed. This is about 10 years ago or whatever. Now it's everywhere. So technology is moving fast, but in the walls themselves for the heating, the R value that we're able to get now versus a solid concrete wall is only R3. That's terrible. It's strong, but it's terrible. But there are closed cell foam, open cell foam, where it's R7 for every inch. You got an R37 wall. Now we can run radiant lines through it. We can run radiant lines down into the ground far enough, and we don't have to heat or cool those lines. We don't have to heat or cool our houses anymore. You got koi ponds, you got hydroponic gardens in the house. We're just around the corner from no one having, between solar and everything, people will not have an electrical bill.
Wow. Now, just your best guess, when do you think that, like, I'm going to use an analogy, right? Electrical cars are now everywhere. 10 years ago, they weren't there. And some people say in 10 years, the regular car is going to be an oddity, that rare. Every car will be electric and self-driving. When do you think we are going to move from traditional house to 3D printed house? Is it 3 years? Is it 10 years? Is it 30 years?
In 5 years, if you don't have a printer, you're out of business. It would be like building a home with a saw, like my grandpa used to use, versus a table saw and a chop saw.
Yeah.
And it's literally that simple. If you don't have the printer, you cannot compete. It's a disruptive technology. Some people get upset at us and say, James, you're killing jobs. I'm like, no, I'm giving millions of people around the world a home. Yep. Okay, because where we're at right now is devastating, and it's destroying the futures and careers of 2 or 3 generations of young people.
James, I want to tell you a historical story that I think really applies here. In 17th century, England, they had steam engines, and they industrialized before any other. That's why they expanded so fast, and they got so much ahead of anybody else. In France, actually, a war was lost. The French lost a war to England because of they were technologically more advanced.
Yeah.
And a French scientist said, we cannot accept that. So he worked a lot on this technology, steam engine technology, thermodynamic, and lots of high-level physics comes from these people. And they started the industrialization in France. And what you just said, that we are losing jobs, was a big deal then, because they put a machine that does the work of 20 people and it runs 24/7, and it doesn't have to take it doesn't have to go to bathroom and so on.
Yep.
And
Doesn't get
French,
sick.
the French are very feisty. They start throwing their wooden shoes in this machine to clog them and put them out of business, literally destroy them. The name of those French shoes, wooden shoes, they are called Zabot, and hence the word sabotage.
Sabotage.
That comes from that what you just described, that lots of people, the
Fascinating.
technological advancement as an impediment, as a threat. Now, we don't have elevator operators, right?
No.
In the 1920s, every elevator by law had to have an operator that pushed a button and make sure the doors are open and closed properly. Are we really sad that those jobs don't exist anymore?
No.
We are not. And I think what you just described, the value it's providing by far overtrumps any question about the job loss. By the way, we don't have enough of those people who build houses for us anyway. So almost it's sarcastic to anybody to suggest that you're destroying any jobs.
Anyone that speaks to that is they're just ignorant. They don't understand history. I can tell that you read a lot. I mean, my grandfather told me a similar story in the 20s when the tractor, a whole bunch of men with picks and hoes and shovels, and all of a sudden a tractor shows up on the job site for the very first time, steam engine, and it can do the work of 50 men. It can move the work of 50 men. And the men were afraid of it. So they went out at night and tried to break the chains and pull all the wires off it and sabotage it because they're afraid. Just go back in a time that I was there for, there used to be, just go back 25 years, you had 1 million people in rooms in every high rise in America typing, doing 10 key, accounting and all that kind of stuff. Are we going to blame Steve Jobs and Bill Gates for their contribution? Err on the side of technology. Where are these hundreds of thousands and millions of people that used to type on typewriters that you brought about, which was an engineering marvel? Okay. Where's the 8-track? Where's the cassette recorder? Where it didn't eliminate jobs. Everybody still has jobs.
It transformed
It's a different type. It improves the quality of the jobs that are available to people. So I can understand the hysteria and getting excited and worrying about this, but right now I'd like to bring millions and millions of jobs back to America. I would like to I'm just hell-bent on an affordable house.
And
anybody that wants to beat on me about that, I'm like, you do realize that 2 or 3 people die every single night in California right now because they got 250,000 people on the streets, peeing and crapping in the gutter, no sewer control, no nothing, the worst living conditions you can imagine. What are we doing about it? We need to make it affordable. How does a girl that works at 7-Eleven or a guy that works at the grocery store afford a $430,000 house?
They can't.
When's it ever going to happen? It's not. We've just dismissed an entire segment of society, and we just turn a blind eye. It's our responsibility.
It has been very well known in all studies and all the documented recent history of economics that the American built value by passing a house from generation to generation.
Yeah.
That process has stopped for a huge segment of society because they cannot afford a house to pass it on. Correct. So I think you are opening a new chapter in U.S. economy that, again, the wealth can be accumulated because people all of a sudden can afford the house. Now, we have come actually a long way, and this has been tremendously educational for me personally. I want to open the panel, and I know that Misha has a lot of thoughts in that. He's usually a quiet person, but I wanted to as well know what your thoughts on this.
So I think to address the housing shortage is a really noble cause. When a person does not have a roof to sleep under, they're gonna be trapped in poverty. and there's no way you inspire the humanity in them. And that's why we see a lot of messed up things happen when people don't have that basic need taken care of. And speaking of like new technology, I myself have been an artificial intelligence developer, and I first-handed developed a solution for our clinic that made some jobs obsolete, and that was a pretty difficult time for me. Like
Yeah.
I see 6 people no longer working with us, but that increased the productivity of our entire organization,
It
that we
lowers
are able
costs.
to spare more resources to help our patients.
Well, but you see, I would say you see 6 people that are not working for us, but I see other 50 people still having a job because we didn't go bankrupt.
Yes.
This is how I see that. But good point that, certainly there's always initially losers and winners of any new technology, but this is a situation that in the long run you're saving more jobs,
Yes.
especially by bringing it to local place than in the long run. But very good point.
And also we have the resources to expand for future.
Exactly.
Well, so many people think the solution is to housing's gone up this percentage, jobs have gone up like that. They think that the government gets involved. Let's make their minimum wage $35 or whatever else. No, Misha, it's how about someone like you develops a technology through AI that allows us to be this much more efficient, which means we can lower our prices. We need to start lowering prices back down. You're never going to catch up by giving raises. The average business, go ahead and raise my prices. If you want me to pay people flipping hamburgers $35 an hour, I'll start selling you a $50 hamburger. No worries. So most politicians, they just don't, they never ran a company. So they just are misconfused.
Absolutely. Every study, every situation has shown planned economy backfires, meaning that you plan to pay people $35 just so they can afford the $400,000. That has a ripple effect, and that planned economy doesn't work. And that is one of that's why we won the Cold War.
Yeah.
Because we proved with that
Sure.
our free market economy is at any corner is more self-regulating than an economy that the government and says you have to sell this for so much or you have to pay this for that much and so on. There is a good school of economy in Chicago, and as a matter of fact, I'm not a big fan of them. You know them.
Oh yeah, I went
Chicago
to
boys.
I went to Chicago.
Yeah, Friedman and all the Chicago boys.
Yep.
They have lots of bad ideas. I don't agree with everything they say, but it is just case after case. They show on examples that the free market regulate itself, and every time government try to regulate it with the artificial means, it backfires every single time.
I think what Misha identified was a short-term sacrifice for long-term sustainability.
Yeah.
Yes. Well,
you should see when we're talking about the homes and affordability or whatever else, when Chase showed me the homes that they're getting ready to build and the design and the aesthetics of these master planned, affordable, most of our kids, they're not drinking the same Kool-Aid that my parents and I did. They're not wanting that $500,000 home. Give me a $150,000 home or a $250,000 home in a market that's twice as much. They want to spend their money on experiences in life, going places, doing things, helping people. It's fun to make fun of millennials and Gen X and stuff, but they are a very conscious-oriented generation of young adults, and we're going to be amazed with the kind of they bring a social conscience that just wasn't there before. But they want a smaller home. They don't want a bigger home. They're not extravagant in the same ways. They want something affordable and aesthetically pleasing. They're gorgeous.
No, and that's the beauty of it, that once you are not confined to quadrangular building, it's amazing what you can do. So this has been amazing. Thank you very much, James. It's really my privilege to have you on our podcast. Chase, thank you a lot for bringing your input. I can't wait to come to the ribbon cutting ceremony when you receive the 3D printer and start actually printing houses. And I'm hoping that we can put as much material, pictures, and so on the DaVinci 3D Tech. That is the your web page. Is that correct, Chase?
That's correct. You can go,
3D Tech?
yes, you can go to it right now and see a rendering of what we're going to do and how we're going to impact affordable housing here in Texas.
We will put a link there, but as well we will put a link to your company, James, so that if people have more questions, they know where to go. I thank you all coming with me on this episode of Essence of Science, Printing Your Dream House. For Essence, I'm Dr. Abbasi.
And I'm Misha.
And you have our guest. Please introduce yourself one more time.
James Lyman, Mudbots, and
Chase Whitaker, President.
Introduce Chase for you.
3D Tech.
DaVinci 3D Tech. Well, thank you.